So welcome to chapter 7, planning and conducting surveys. This is also a relatively short chapter, but there's one very important component. Okay, yeah. So we'll start with that very important component called SRS, simple random sampling. Is it sampling or sample? Yeah, it's sampling. Okay, simple random sampling, SRS. So this is probably, from here on until experiments is over, this is probably the most important thing. Simple random sampling. Okay, so what does it mean? So say you have a population, like my wonderfully drawn figure over here. Say you have a population of 6 people, okay, and say you want to divide them. Okay, not exactly divide them, but say you're selecting samples. Okay, you're selecting samples of 2 people. Okay, so how would you? So simple random sampling says, we discussed last lecture, that you don't want bias, right? You want to represent everyone in the population. So if you're picking a sample, you want to make sure that every single one, every person, okay, every person has an equal chance of being in a sample, okay? So that is the biggest tip, and this is called simple random sampling, right? So you want to make sure that everyone has the same chance, okay? So another way to define this is that every sample of size whatever n has an equal chance of being selected. So I actually don't know which interpretation is right, but what I always try to think of it as is the chance the same? Okay, is the chance that I'm going to pick 2 people for a group the same, or is the chance that I think they are the same? If I'm wrong, please correct me, but I think they mean mostly the same. Let's think about it. Yeah, I don't know. I think so, but yes, this is definition you should memorize well, and not memorize, but understand what it means. It just means that you're giving everyone an equal chance, or like the book says, you're giving every sample an equal chance of being selected, every possible imaginable sample of being selected. Okay, now, so there's 2 ways to do SRS. You can have a random number generator, I'll just call it RNG, or you can you can pick names out of a hat, things like that, or you can assign numbers. Okay, assign numbers. So let's go back to the sample. Say you wanted to pick 2 people, right? So you would assign all these numbers. You would say 1, this guy's 0, this guy's 1, this guy's 2, this guy's 3, 4, 5. Then you would go to a random number table, and then whatever, right? You pick the first 2 digits, and okay, so you've got to specify rules as well. So in this case, for example, it would be, you have your random number table. Say it was 5, 9, 7, 1, 2, and then some. Okay, so you would go first digit 5. Yes, I want to 5. So you pick 5. Okay, to be the first person, and then you look at 9, or like, nope, there's no 9, so I move on. No 7, and then I do have a 1. So 5 and 1 is your first sample. Okay, so you must specify all these rules. You must tell them that which numbers am I including, which ones am I not including, when do I stop. For example, here you stop when you get the second number, so you need to tell them everything. And a random number generator is, of course, you would just generate a random number between 0 and 5, and then you would those 2 people would be your sample. Okay, yep, that is it for simple random sampling, the most important thing in this entire chapter. Okay, and okay, so moving on to sampling error. sampling error. So as the name, contrary to the name suggests, it's not really an error, it's a variation. Okay, so what this is really saying is, if I have a population, say my, how do I describe this? Okay, it's basically saying that all of my samples may look a little different than each other. Okay, and this, you can find out why this makes sense going back to the last video's example of classroom sizes, right? If in one sample it is entirely possible that the average classroom size is higher than in another sample, okay? But the key, so it's not an error, okay? And if someone tells you that this is a bias, well, it's not a bias. It occurs naturally, okay? But what is important is that this variation decreases as you increase. Sample size. Okay, because think about it, and that is tip number 2. And think about why this is the case. Well, it is the case because since you have a larger sample, because you have a bigger sample, the averages will come out to be roughly the same. Because now you have a little more spread in your, actually not a, you have a little less spread, but the point is, that's not the point. The point is that as your sample size becomes larger, because you're having more things, there's a higher probability that you're getting those things from different parts. So say your distribution was, this is a bad analogy, but say your distribution was something like this, right? If your sample size was small, say you got 2 points from here, okay? But if your sample size was like big, 5 samples, you make it 1 from here, 1 from there, 1 from here, 1 from there, and 1 from there, okay? So as you can tell that these 5 points represent the population much better than these 2 points, right? And then therefore your sampling error decreases as you get more, as your size becomes bigger. Okay, okay, now sources of bias. So the rest of the chapter is devoted to biases. So biases, are they C's or says? Okay, bias is something again that basically corrupts your data and then you cannot use it anymore. So I won't go over all the biases, you can read them yourself and you should have read them. But the most important ones are response bias and response bias. I will write these. So you have response bias, and then you have undercoverage bias, and then you also have wording bias. Yes, and then you have wording bias, and then you have something I called the housing bias, household bias. Okay, so let's go through these one by one. Response bias basically means that if you're asking someone about a controversial topic, and people generally tend to not tell you what he or she actually thinks because it may be unpopular, so that's response bias. Undercoverage bias is, for example, say you're serving everyone, you're calling everyone and asking them about something, right? So the problem with this is you miss out the homeless people who don't have a phone. So that's undercoverage bias. Now wording bias is tricky because wording bias is, if you word the question in such a way that it's leading as in you're pushing someone to get to a certain conclusion, right? That's wording bias. And then there's something I called household bias. Household bias is basically if you go and knock on everyone's door and you ask each house for something, well, the problem with this is there may be more than one member in each household, and you might not be getting the actual. You might not get the actual. You don't represent the population well enough, okay? Because you're not asking everyone for opinion, and the person giving the opinion may have a different opinion than everyone else in the house, right? So those are the first four biases. Response and undercoverage are they have the most questions on them. Okay, yeah, that's it. There's just one more thing, which is, okay, yeah. 1 second. Oh, also, there's this thing called convenience sampling. So convenience sampling is, which is a bias, by the way. So convenience sampling is basically, for example, you go to a basketball game between two teams, and then everyone who enters the stadium for that game, you ask them what's their favorite team except these two teams, or something like that, right? And because they've come here to watch that game, there's a high chance that one of those two teams is their favorite team and not any other team. So you would be actually, wait, no. So, okay, I will make this clearer. Say you have teams A and B at a baseball game. Okay? And then say this is the stadium and people are entering, and you are over here. And you ask these people, what is your favorite team? Well, it's got to be either this or this, right? That there's a high probability that it's either A or B, because these people have come to watch their game. Okay? So, and then the problem with this is, if you say then, well, okay, so what's the problem? The problem is that your responses will only include mostly team A or B, so they don't represent the population. And again, the entire idea of a bias is that the biases don't represent the population well enough, right? And over here, you don't represent the population well enough. So convenience sampling is something that's not in the book, but it's pretty important. I mean, it's in the questions, but they don't cover it. So convenience sampling is important. Okay, finally we get to other sampling methods, which is stratified and cluster. Okay, so stratified sampling is characteristic sampling. So if you have a how do I describe? Okay, so stratified sampling divides the people based on a certain characteristic. So the keyword there is characteristic. Okay, so for example, say I want to say I want to do something, but so examples are like I can make stratas of people by height, by age. There you go. So say I wanted to I make stratas of people by age. So this group is people of age 50, this is people of age 20, something like that, right? And then, so how stratified sampling works is then after you have your stratas, which have individual characteristics, in this case age, then you would do is you would choose the people from each strata. So you would randomly choose people from each strata, and you would do this for each strata, so you can represent the population. So you choose people from each strata. Okay, that is how stratified works. So they call it homogeneous because again, everyone in this bubble has the same characteristic, namely they're all 50 years old, right? So there's stratified sampling, and this is beneficial when you want to have you want data about certain people or places in the population. For example, say you're interested in how different ages contribute to something, maybe smoking, whatever, right? How do people of different age groups tend to smoke or whatever? So you would go with you would stratify it. And then you have cluster sampling, which is basically, instead of dividing it into specific characteristics, what you do is you just divide people. So the best example I have for this is neighborhoods. Say this is a state or province, okay? Now say I divide it into 4 parts. Okay, and then, so I've already randomly divided it, right? If I just look at this, I'll call it A, B, C, D. If I just look at C, well, the people in C are random. I don't know who's in C, I don't know who's in D. It's not like stratified. I don't know who's where, okay? So I just divide it into 4 parts. It's heterogeneous, so everyone does not have the same characteristics. There's all kinds of people, and so it's random that way. And then you just you choose one cluster. So you choose one cluster, and then you use that cluster for your study. Okay, so that's the main differences. In stratified, you take people from each strata, but for cluster sampling, you only take one cluster. Okay. Okay. Yes. So in clusters, basically each cluster should represent the entire population, and you already know this, because otherwise you wouldn't be using this type of sampling. What else you need to know? Oh yes, there's something called systematic sampling. Which basically arranges the entire population alphabetically or in some manner. Say I arrange it alphabetically. So I have all the restaurants starting with A, and then I have all the restaurants starting with B, something like that. Okay. Then what I do is I pick a place to start. Say I want to start here. So I pick this restaurant, and then say I want to pick every 10th restaurant after this. So the next restaurant I pick will be here, the next here, the next there, something like that. And then this guarantees a random sample. The last point, tip number 3, is that stratified and cluster sampling are not, they won't result in a simple random sample. Okay, and you should reason this out, because if you can reason this out, you'll get most of the questions, because this is a very fundamental test, is to see whether you can analyze what is an SRS and what's not an SRS. So if you can understand why stratified and cluster sampling are not an SRS, then you'll be set for most of the questions. Okay, is there anything else? I think that's it. Yeah, I've covered everything. You can read up on the biases, but there's not many of them. You just need to know these 4. Yeah, as long as you know these 4, you should be fine. Yes, again, the biggest thing here is sampling variation, and apart from that, I think that is it. So, yep, you are done. And we'll see you in chapter 8, which is the last chapter for theme 2. Okay.